All right, let's take a look at classifying real numbers, and then we'll do some ordering of real numbers. So far, you guys have just probably known numbers as being numbers, and you recently learned that we have rational and irrational numbers. What you may not know is that we can put all, whoa, let's undo that one, hold on. We can do a diagram, that's still not great, where rational and irrational actually fall under the classification of real numbers. So this is kind of our umbrella so far of numbers that we know to exist. And inside of this, we have rational numbers, which are most of the numbers that we deal with, right? So you have any number that can be written as a fraction, decimals, negatives, positives, whole numbers, zero, all of those are rational numbers. And you guys are writing all this down in your math notebook, okay? So if you need to pause to catch up, go ahead. But make sure if I'm writing it, you're writing it. So within rational numbers, we have integers. And then integers are whole numbers that are positive and negative. And then within integers are the numbers that you most often are, it's the numbers that you started dealing with, which are just the whole numbers. So these are numbers, you know, anywhere from 0 to and greater on a number line that are whole numbers. So let's just do some examples of each kind, and then we're going to fill in this space over here. So far, we have real numbers that consist of rational numbers. Some examples might be 1/3, 4.7, negative 2/10, negative 5/6. Maybe it's the square root of 16, right, which is 4. And we'll throw one more in there, and we'll just say it's negative 10 513, something like that. So those are all rational numbers. Integers are just our whole numbers and their opposites. So we could say negative 4, positive 4. We can say negative 16, positive 16. We can say 1, 2, 3, negative 2, negative 5. So those are our integers, and then whole numbers, we would just want to list any numbers that are whole and are positive. Something like that. But also under the real numbers kind of umbrella, we have irrational numbers, which we also just learned about. And irrational numbers are also real numbers. They're numbers we know to be real. There's some sort of way of proving that they exist, so that makes them real numbers. And we learned that the square root of 2 is an irrational number because 2 is not a perfect square. It results in a decimal that goes on forever and has no repetition of numbers, so no repeating pattern of any kind. Pi is also an irrational number. We can say that negative square root of another number that's not a perfect square, 20. 20 is not a perfect square. So really here what we're thinking is mostly it's just numbers that are not perfect squares. The square root of a non-perfect square, that is. So those are our irrational numbers. So when you're asked to classify them, if it's just simply a whole number, and that's an option, it would go here. If it's negative, and it's the opposite of a whole number, right? So 16 is a whole number, negative 16 is opposite. Those are both integers. Rational numbers is when we get into the things that have pieces, right? And it can be either a repeating decimal, like 1/3 repeats, or a terminating decimal, like 4 7/10. It could be positive, it can be negative, it can be written as a fraction, okay? And then irrational, you're gonna wanna put all the numbers that, if you notice right off the bat, it's the square root of a number that is not a perfect square, it's irrational. If it's pi, it's irrational. Pi repeats, it doesn't repeat. It goes on forever and it doesn't have a repeating pattern, right? So that is the definition of an irrational number, is if it goes on for forever and it doesn't have a repeating pattern of any kind. So that's the gist of that, okay? Let's clear this. Now let's take a look at how we would order real numbers. Now, I'm going to throw some, one of each kind out here. Okay, so let's look at, we want to order 1/4. Maybe we'll do 0.05, so 5/100. Let's throw a negative in there. We'll do 2/5, -2/5. Pi, we'll put pi in there. And maybe we'll do the square root of 5. 5 is not a perfect square, so automatically we know we have 2 irrational numbers in our list, and then we have some rational numbers in our list. Let's throw an integer in there. Let's do -3, okay? So how we're gonna do this is, and you can check all of these with, you can do these fractions, convert these to a decimal with a calculator. So it's kind of like when you think about ordering fractions, but they're not in the same amount of pieces. It's real hard to tell what the value is of those fractions unless we get them like that. We don't want to convert everything to fractions, and actually we can't because we have irrational numbers over here. So we want to get everything to some sort of a decimal form so we can really precisely order these. Now the best strategy to use, once again, is a number line. And so we need to look at what's our low and what's our high. But first, let's convert some of these to make more sense of them. Well, we know that -3 is -3. 1/4 is 25/100, right? This is 5/100. -2/5, you would just simply put that in the calculator. So 2 divided by 5, 4/10, and you would put the negative with it. So 4/10. Pi is approximated at 3.14. And then the square root of 5, remember how to do that in the calculator. You put the 5 and then the square root symbol. And we get 2.236. And we'll just stop it there. So it's real nice, guys, when we're converting our irrational numbers to decimals. Go to the hundredths, round at the hundredths. So I'm gonna put a side note. Round at the hundredths place. That just gives you a more precise value. And we're rounding irrational numbers to the hundredths place, okay? All right, so let's get to ordering. So first thing you need to do is look at your values. What's the lowest and what's the highest? Because we really don't need to put, zero. I mean, we're not starting at 0, we have negatives, and we don't need to put a lot of values on there that we're not using. We're only using the ones that are a purpose, that are helping us. Well, I can see here that our lowest term, and lowest value is -3. So I'm going to start it on the left side at -3. Let's look at the highest value. Looks like pi is our highest value at 3.14, which is pi approximated, right? It's not the exact value because pi is irrational. And then this is about 3. So I'm just going to scoot over a little bit more, and I'm going to say that this is the whole number 3. And then halfway in between, right, same distance from 0, is my 0. Okay, 3 units, 3 units. Let's go ahead and mark. This is 2, this is 1. Oh, these are negative. And then here we have 1, and here we have 2. Not perfect, but something we can work with. Now let's start seeing where we can place these values. So we know our -3 goes here on -3. So I'm just going to change the color, make it stand out more. And what do I want to use? I'll use the screen. So -3 obviously is going to go right here. Okay. And 0.25 is a quarter, right? It's positive. And it's a fourth of the way between 0 and 1. So we're going to put it somewhere right about here. This is 1/4. Okay. And you guys, some strategies to help you too when you're doing this is you can, check them off. So you know you've used them already. You don't have to keep looking at those ones. Now we have 500ths. 500ths is pretty small. Let's keep going and see if we can get more precise with these other ones first. Here's 4/10, but it's -4/10. 4/10 is almost 5/10, which is that's exactly 1/2, right? So 4/10, if this is a -1/2, 4/10 is going to be a little bit closer to 0, right? So this is -4/10 right here. Okay. We use this one. 3.14 is pi. We're just going to stick that right here. We use that one. 2.236 thousandths. Well, 2.5 is right here. And that's about halfway in between 2 and 2.5. So we're just going to kind of guesstimate that it goes right here. 2.236, somewhere right here. And now we've got our last one, which is 500ths. That's a very small number, right? That's 5 pennies. This is a quarter. So we need to squeeze this one. I'm going to kind of draw an arrow right here, real close to the 0, and put 500ths right there. So this is how you order real numbers. Real numbers, remember, includes rational, irrational, and rational includes integers and whole numbers. And this is the strategy that we use it in. So once we've done our number line and we've gotten as precise as we can, we now just write them in order from left to right. So we have -3, -4/10, no, that's a positive, 500ths. Okay, we have 1/4. So at this point, it's okay to write it in original form. All right, so don't keep them as decimals. That's why we wrote them like this on our number line. We want to write them in an original form. And then oh no, I just said that and then I didn't do it. Goodness gracious. The 2.236, we should have actually, we should have put it as the square root of 5. That's what that was. So square root of 5. And then pi. Not missing anything, are we? Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so that is how we order rational numbers. It is okay to convert our fractions to decimals. And our irrational numbers, like when we had square root of 5. It's okay to convert irrational numbers as well to decimals. What I'm going to say is with a calculator. All right, but you've got to be able to show how you order them on a number line. And this is where the precision and the proof comes in, okay, to your work. And then you can rewrite everything like this. Super, super important concept. So I'm going to give you a few practice problems for both of these where you're going to classify your numbers and you're going to do some practice with ordering them. And then it's pretty much it, guys. We're done with this lesson. There is going to be 4 questions on our district common assessment. Remember, that's not a final exam. It's just a check-in to see what you've retained. There will be 4 questions that have you doing things like this, okay? Ordering real numbers, knowing what's rational and irrational, and I think that's pretty much it, but there's going to be 4 questions on that. So please, please pay very close attention, take organized notes, and work all your practice problems out in your math notebook so that you can have some great study material for when you're ready to do your check-in. Because I will be using these 4 questions on this common assessment as your quick quiz for this module. Okay, happy learning.